All right, hey everybody, welcome to the talk. I'm glad to see so many people are excited to learn about how to build for visionOS with Unity. And without further ado, let's get started. So just a quick intro, my name is Matt Schoen. I'm a software engineer. I've been working at Unity for about 7.5 years. Before then, I started an indie game studio called Defective Studios, making first and third-party games and apps with Unity. So my journey with Unity has gone a long time. When I joined at Unity, I started working at Editor XR, then Project Mars, the AR companion app, and now I work on the PolySpatial team, bringing visionOS support to Unity. Just a quick notice that the lawyers asked me to put in here. Everything we're talking about today is forward-facing, experimental packages. Things may change. I ask you please don't base any purchase decisions or consider anything that you see here as set in stone. These are evolving technologies, and things may change since this talk. So, I want to give you guys a brief overview of what you're going to see today. You're going to see an introduction to Apple's visionOS operating system. You're going to see how we've created support for visionOS with Unity. I'm going to bring Pawel Pilacki on stage to talk about some of the experiences that Resolution Games has had porting their games made with Unity to visionOS. And then I'm going to share some helpful tips and tricks, resources, and things that you can use to get started today. So in case you haven't heard, Unity is excited to collaborate with Apple on support for the Apple Vision Pro and visionOS. As you may have heard at the keynote this morning, we are opening our beta to pro, industry, and enterprise users. That means anyone can go out today, download Unity 2022.3, download our packages for PolySpatial and visionOS support, and get started. So, let's talk about some of the foundational concepts that may be new to you or new to mixed reality and visionOS. And it's going to give you some context for how we've built support for these various concepts in Unity. So there's two types of ways that apps can present content to the user on visionOS. One is in the shared space, where multiple applications can present windows or volumes that contain 2D or 3D content, and users can reposition and open and close these volumes at will, much like the macOS operating system, where multiple applications can run and present windows to the user. There's also the immersive space, which is a way for apps to be able to create and present content in an unconstrained, unbounded way all around the user. An app can choose to open an immersive space, and if it is the foreground app, it will launch the immersive space. All other apps in the shared space will fade away, and you will be immersed in this singular app with windows, volumes, and objects all around you. So as a brief demo, I'm going to switch over to the visionOS simulator, which is part of Xcode. Again, you can go out and get the Xcode beta today and get this on your Mac and play around with it. So as you can see here, the simulator window I have open shows you what you might see in a Vision Pro device with a virtual environment. I can two-finger click and drag to look around. I can use the WASD keys or a two-finger pan to navigate the environment. Again, if you're familiar with our AR simulation, XR simulation features in Unity, this is very similar, or some of the other simulator apps that are out there. I have the home screen available here. I can kind of like swipe back and forth to look at the apps that I have available. I should have mentioned, the way that you would do this on a Vision Pro device is by gazing at a particular affordance, pinching your fingers, and moving your hand around. So this is kind of the point and click or a touchscreen tap equivalent for the Vision Pro device. So you see here I have apps that I can launch much like an iPhone home screen. I can gaze and tap on an app and it'll be presented to me in a window. There are these other affordances that I can use to use the freeform app. And then there is this Chrome at the bottom that I can use to reposition. You see it sort of goes transparent as I move it around. The one thing you're missing here is that you can also push and pull in mixed reality to move the app further in closer to you. There's also an affordance that will show up when you gaze at the corner to resize and scale the window. Again, these should be familiar concepts to a windowed operating system, much like macOS. On the device, I could press a crown button to open the home screen. In the simulator, it's up here. Again, we'll see the home screen. I can go launch another app, say like Photos. And here we have two apps existing side by side. So you'll see that as they overlap, the background app will be faded out. I can interact with another app and bring it to the foreground. Again, this is how computers work. But this is how computers will work in mixed reality. Finally, I have an app that is basically just the Xcode template project that I've built here to demonstrate immersive space. So it launches in a volume. As you can see, there's just like a sphere that sort of is floating in space as well as a small UI. And it, again, will fade out the apps behind it and coexist in the shared space. You can't really read it here, but this affordance is called Show Immersive Space. When I click on that, all the apps fade away, and now I have these two extra spheres representing your immersive content. And this is what happens when apps will transition in and out of the immersive space. I can turn this off again, and then here you see my apps are all available. I also just want to point out that I'm not the source of truth on this. Obviously, this is all Apple software and Apple operating systems, so the best source of information for that will be the WWDC talks from back in June. Two of them were co-presented by people from Unity, so they'll be particularly relevant, but I also encourage you to just kind of go and browse and learn more about visionOS from Apple. Going back to the slides. Let's talk a little bit more about the shared space. So apps can use volumes to show content, and users can reposition these volumes as you've seen. Users can interact with the Chrome on the volume itself, as well as the content in the volume. So the app that I showed you with the sphere wasn't interactable, but those little slider toggles were. And again, this would all be done by gazing and pinching. There are also some other accessibility options that you can use, like a wrist-based ray or that kind of stuff. Again, go see Apple for the real authoritative information here. As well, apps can open and close an immersive space. So this is like an option that the app will elect to do or not. As you saw, when it opens the immersive space, all the other apps will disappear. You can place content out around the user without any kind of constraints. I should mention that the volume gives you a constraint where you ask for like a meter by meter by meter cube. If your content veers out of that cube, it will be clipped. You'll see a little bit more of that in later demos. And also importantly, when the immersive space is open, ARKit features are available. So what are the ARKit features on the device? There is a new feature called hand tracking that will give you skeletal tracking of all of the joints of your hands. And then some other features that you may be familiar with from ARKit on phones, room meshing, plane detection, image detection and tracking. One more that I'm not remembering right now. Oh, head pose, so like camera tracking on a phone, and of course hand tracking that I mentioned. I should also note that not all of the ARKit features that are available for phones are available in visionOS at the moment. This may change in the future, but for now you're limited to those 5. Finally, there are 3 different sort of modes or types that the immersive space can take on. A full immersive space is like virtual reality. It completely overrides the pass-through. Again, you'll see another example of this later in the talk. And that is, there's no access to pass-through. The user's hands can poke through the pass-through, through the virtual content if you so choose, but it is a lot more like a traditional virtual reality app, no pass-through. Mixed reality blends content with pass-through, so you can have sort of both simultaneously, like you saw in that example that I showed you. That was a mixed mode immersive space. And then finally, a progressive virtual space is kind of a mix of the two. There is a virtual background as well as mixed reality content, and the users can dial that little crown button on the device to essentially change the field of view of that virtual background. So they can have a little bit of a background or elect to be completely immersed. So with that out of the way, now you know a little bit more about visionOS. Let me talk about some of the application types that Unity exposes to you in order to target this platform. So there are 3 application types. The first one is mixed reality. So mixed reality is, again, like what you saw in the simulator, except rendered with Unity. And there's the caveat that in this mode, Unity uses Reality Kit to render, while all the other Unity features like physics and animation and things are handled by the Unity player itself. I'll dig into this a little bit more, but this is sort of the main driving factor for this new technology called PolySpatial. And it enables Unity content to be rendered on the visionOS with pass-through. Virtual reality should be much more sort of familiar to XR devs in the audience. You do have access to metal rendering. It is a build target just like anything else, and most / all of the existing packages that you're familiar with, like XR Interaction Toolkit and AR Foundation, as well as the render pipelines, will work in virtual reality mode. And then finally, a windowed app, which is very much like an iOS app. If you're using the existing touchscreen API, visionOS Gaze and Pinch is forwarded through the app as touch input. It renders into a 2D window like the Notes app that you saw, or sorry, the Freeform and Photos app that I showed you. And non-XR content that's built with Unity should be able to port to this mode very easily. So let's dig a little bit more into the mixed reality mode. It blends the physical and digital world, so you can put your virtual content on top of the pass-through, using some image-based lighting, the physical-based material from RealityKit. In order to make this as seamless as possible, what we've done with PolySpatial is mapped the Unity standard and URP lit materials to the physically based material in RealityKit, as well as some other kind of simple mappings that you can use to render your Unity content with RealityKit. But I'll get a little bit more into the caveats there in a bit. As I mentioned before, there's immersive space and shared space. Unity apps can also take advantage of these two places. So in the Unity editor, we have this component called the volume camera. It defines whether you're in a shared or immersive, whether you would like to put the content in that volume into a shared or immersive space. And you can swap the mode on that from bounded to unbounded. And as I mentioned, when you have an immersive space open, ARKit data is available to you through Era Foundation. Okay, so let's talk a little bit more about PolySpatial and how Unity renders in the shared space. So as you can see in this diagram, on the left side we have the Unity simulation. This is what you should be most familiar with. You can do physics. The assets are built into the player. It is a normal Unity build, but for this new build target, visionOS. And then Unity PolySpatial bridges the gap between Unity and RealityKit by taking transforms, renderers, materials, definitions for colliders, and replicating that in RealityKit with RealityKit entities. And then from there, RealityKit takes it from there. It uses image-based lighting. It uses other features of the operating system to render your content in the virtual world, and in a way that it can be faded in and out, and all the things that you saw in that earlier demo. And then finally, PolySpatial's RealityKit component sends back input events from the gaze pinch interaction, as well as the AR data and other kind of data from the operating system back to Unity. Other integrations like audio and internet access and those sort of things work just as they normally do on iOS. Unity has direct access to those parts of the hardware. Finally, I wanted to share some pro tips, or just kind of individual little things to take note of when working with PolySpatial and mixed reality apps. If you have custom shaders that are written in our shader lab or HLSL language, you will need to convert those materials to shader graph. This is because we can enable custom materials in RealityKit using a technology called Material X, but in order to convert shaders from Unity to Material X, they need to be presented in a node-based format. This is going to be one of the most major challenges for porting existing content to the mixed reality space, but we're doing our best to kind of give you all of the workflow improvements and helpful things that make this porting process easier. There's also a project validation feature that is already used by a lot of the existing XR plugins and packages. This will give you kind of a feedback in terms of your project settings and things about your active scene and anything like that give you that guide you toward configuring your project correctly. I really advise you to check those out. And then we've also added some new rules specific to PolySpatial, not just visionOS, to help you understand things like particle systems or terrain and LOD, some of these rendering features that are not fully or maybe not partially supported. I should mention in terms of feature support, things like post-processing effects or anything that uses a full screen render target are just impossible in mixed reality on the platform, so they're not supported and they won't be in the future. Other features like I mentioned, terrain, trees, LODs, that kind of thing, those can be supported in theory. We just haven't kind of gotten there yet. And you can refer to the documentation for the PolySpatial package online for a more detailed breakdown of supported, unsupported features. Moving on, we've introduced a new type of interactor for the XR interaction toolkit. The XR touch space interactor, which is in the polyspatial.xr package, gives you a kind of more direct route to do interactions with a gaze and pinch gesture. It avoids having to do a raycast within the Unity scene because visionOS will give us the specific RealityKit entity that was targeted by the interaction, and we can kind of backpropagate that to the game object that was being clicked on, and that gives you a kind of more direct interaction path. All of that is provided for you in the PolySpatial package, but if you're using an existing scene with XR interaction toolkit, you'll want to bring in this interactor on top of your existing setup. The next thing is kind of just good general advice for Unity, especially on mobile platforms or things that kind of aren't the standalone Windows, Mac, and Linux platforms. I encourage you to start small, small scenes with not very many assets, projects that build quickly, things that you can test often. Basically, there will be some issues that you encounter along the way, and it's much easier to recognize, fix, remediate those things early on in the process with a small project that is simple and kind of easy to narrow down. Also, if you run into trouble, like app crashes or unexpected results, please go check out the FAQ and the general documentation online. The FAQ should run down a lot of kind of like, common snags and trouble points. And as well, obviously, the documentation will give you lots of information about the features that you want to use. And I also encourage you to explore the templates and samples that I'm going to give you an overview of later in the talk, just to kind of get yourself familiar with what's possible in the platform, how to set things up, best practices, that sort of thing. Now, I'm really excited to show off this feature. This is something that I've kind of always wanted for Unity development, and it's enabled in a unique way with PolySpatial and visionOS. There's a feature that is new to this latest release of the package that just came out today. It's called Play to Device. It allows you to press play in the Unity editor and immediately see your content and your app appear either in the visionOS simulator or on a device. It streams the PolySpatial data over the network. The Reality Kit on the device presents your content to you, and input and data is streamed back to the editor over the network, giving you this tight integration and fast iteration. So you can deploy using Play to Device without building through Xcode, and you can access play mode features like the inspector or the transform handles and that sort of thing. So hopefully this will work. I got a live demo prepared for you. You know how these things go. All right. So back here in the visionOS simulator, I'm going to close some of these apps that I opened earlier. I'm going to open this Play to Device app, which you can download through our discussions forum, or on the device there is a test flight link on the discussions forum as well that you can use to install the app on a device if you have access to it. It's going to give you a kind of helpful piece of information that you're ready to connect, and this is the device's IP address. Since this is a simulator, I can just use localhost. But I'm going to go back to Unity. I'm going to go to the PolySpatial menu, open the Play to Device window, and you'll see here I already have the option checked to connect the player. I can leave the default localhost IP address, but if I was testing on a device, I would use the IP address I see here. And without further ado, press play. Hey, there we go. All right. So as you can see, yeah, all right, come on. All right. So as you can see here, I have my volume in visionOS. I can move around and kind of see what it looks like from different perspectives. I can interact with the content in here, and you can see it both replicating in the editor and on the simulator. I can also go back to the editor and do these interactions in play mode as well in the game view. I can look at things in the scene view, kind of have these extra controls. These are interactable objects, so I can't really move them around without them freaking out. But you can see here also I have the inspector, so as I show these two things side by side, as I operate and move this object around, you'll see the data changing in the inspector. And I can also go and do things like modify materials. Again, basically anything you can do in play mode, you can do with Play to Device, and you'll see exactly what it's going to look like on the simulator. Just to milk this demo a little bit more, I'm going to show you a different scene. And again, I can start and stop any play mode session I want. I can move the volume around and sort of play around with those features. You see here we have some animated characters shown off. And as well, I can go and use the scene view and make some tweaks to my scene if I want to. So again, we're really excited to show off this feature. I've always wanted this kind of thing for Unity for mobile development and things. So it's really great to see this kind of improvement to workflow and iteration time coming out of PolySpatial. So that went well. All right, I got my backup video that you don't even need to see. So that was mixed reality and PolySpatial. Now we're going to kind of transition to the second app mode, virtual reality. So PolySpatial is not in the loop here. All you're doing is using the xr.visionOS plugin provider for XR Foundation, XR Management, sorry. And this allows you to render with metal, so those constraints that I mentioned earlier about rendering features and converting to shader graph do not apply to virtual reality. But unfortunately, you don't have access to pass-through video. So it is a kind of choice that you have to make when you're deciding how to target the platform. Do I want to go ham with my custom shaders and stay in virtual reality, or do I want to take advantage of pass-through and use Reality Kit for rendering? Another caveat that's easy to miss is that unlike a lot of the other XR platforms, you need to have an AR session in your scene for virtual reality to work. This is because, as I mentioned earlier, the head pose where the user is looking is exposed through ARKit. There needs to be a running session. The way that we expose that to you in Unity is through AR Foundation and the AR session component. So a lot of kind of like first timers will say, hey, my content is headlocked. Why am I not getting input? It's because you need the AR session. Oh, right, I also have a VR demo. So let's go back to the simulator. So again, just like with mixed reality, VR also works in the simulator. I have here a VR app that I built earlier. Man, this demo was pretty reliable before. Let's just try this one more time. Well, okay. I would be showing you our beautiful new URP Japanese garden demo. I'll see if there's a little bit of time later to like restart the simulator and try that again, but the app isn't launching. I got all excited about the demos working. Okay, and now finally there are windowed applications where without any of the PolySpatial or XR plugin packages in your project, if you target the visionOS platform and build, you'll get an application rendered to a window like you see here. It's almost identical to an iOS app. It uses touch input, it renders with metal, and it will exist in the shared space in a single window. No options for immersive spaces or anything like that. Obviously, you'd need to use PolySpatial to enable those features. All right, so and as I mentioned, we have some resources for folks to get started today. The first is the visionOS template. So there is a new template for visionOS specifically. We will probably end up kind of merging this with the mixed reality template as a whole, but for now, they're still separate things. It is available through the discussions forum. You can download a zip, and it is a full Unity project with some sample content and two sample scenes, one set up for a bounded volume-based interactions, one set up for the immersive space. All the project settings and package setup and all that kind of stuff is pre-configured, so it's the best way to kind of just get out of the box and start going. And we will also be putting out a template for VR. At the moment, you should be able to just flip the app mode for the MR template and test out virtual reality as well. Furthermore, there are some samples in the package itself that you can get through the package manager UI. It's a bunch of sample scenes and the assets and content that kind of drive them. The first scene is a project launcher with this kind of nice little aesthetic with the preview of each scene in these little bubbles and some UI to switch between them. You press the arrows, you press play, you launch into a particular scene. In the middle here, we see the object manipulation scene. That was the one that I was using in the play to device demo. Just some basic cubes that you can pick up, toss around, see what object manipulation looks like. And finally, the balloon gallery demo is kind of my favorite one. It's almost a full-fledged game. It uses input, it has particles, it has audio, it has kind of, the score tracking and stuff. So just really integrates a lot of the different features and shows you what a real game might look like in mixed reality. And of course, Unity has a wide variety of tools and workflows that aid development for virtual reality and mixed reality. The XR simulation feature that's part of AR Foundation allows you to test in the editor in play mode features that are based on mixed reality or augmented reality features like meshing, planes, image tracking, etc. The XR device simulator that's part of the XR interaction toolkit will let you simulate hand interaction specifically with the skeletal mesh that you get from ARKit. And then also the XR Interaction Toolkit comes with a variety of demos, templates, and sort of like building blocks that you can use to get started in a sort of a more advanced interactions right out of the box. All right, so with that, I would like to welcome Pawel Pilacki on stage to talk about Demio and resolution drawings.
Okay, hello everyone. My name is Pilacki. I'm a senior MR developer at Resolution Games. I've spent the last 3 years driving Demio to the various platforms like 2D, virtual reality, and mixed reality. Since my dive into HoloLens in 2017, I've been immersed in the world of mixed reality, captivated by its potential and possibilities. I'm very excited about the Unity PolySpatial technology and how we'll expand Demio to the rich new platforms. So, what exactly is Demio? Demio is a captivating cooperative adventure game for up to 4 players. It recreates the joy of tabletop gaming with friends as you work together to vanish evil forces. Demio demands strategy, teamwork, and offers 5 unique adventures in the fantasy world. Demio extends its reach across various platforms, offering the choice of both immersive and 2D experiences, while seamlessly enabling crossplay between them. Now, with the new visionOS platform, we can blend both worlds together. Here, you can see a short example of the gameplay and our mixed reality integration to the other platforms. Our game allows you to seamlessly transition from VR to mixed reality. The game is 100% playable with the hand tracking, and you can instantly switch to the controllers if you want to. So now let's explore the visionOS, a platform that offers diverse ways to launch and enjoy the game. Given that the Demio is available in both VR and 2D, introduction of the windowed mode was a natural decision. Best way to approach that is having the game working on the iOS platform. Porting to this mode is a straightforward process, and this is primarily because the mobile touch inputs seamlessly transition to the visionOS. Users can leverage both hands to control the game. The game will work exactly on the other platforms, except to use the hand tracking and eye tracking to manipulate it. The most fun in the game is definitely in the VR, when you can totally dive into the different Demio adventures. It's pretty easy to make sure that the game looks good in the full VR, thanks to metal rendering. Here, we don't really need to care about the environment reflection props or the lights, which is very convenient. Since initially we used the built-in render pipeline, we didn't get the forward rendering out of the box, but I will chat about this a little bit later. So last but not least, the mixed reality mode, where you can leverage both bounded and unbounded mode. Running the game with Reality Kit is very challenging, and what Unity done here is really astonishing. In terms of visual design, we are still trying to figure out how to leverage the environment lighting while preserving the original look and feel of Demio. One of the Demio features is the ability to move and scale yourself in the game. Within the gameplay, players can dynamically move directly into the battle. And previously, on the other platforms, we achieved that by adjusting the player avatar. However, with the PolySpatial, we have something called volume camera, and you can control that to kind of scale and rotate and move your world. There is a lot of potential going from unbounded to bounded mode. Just imagine that the game switches to the shared space, and now we have freedom to do all the other cool stuff that Vision Pro allows us to do. And the game is just add-on to our real world, and the game just blends next to it. So let's talk a bit about particles. They are the most challenging aspect of the PolySpatial technology, and only utilize a fraction of Unity's particle systems. So in case of Demio, while all VFXs rely on custom shaders, like conventional methods become nearly impossible for us. So to address this challenge, there is something new solution from Unity in the PolySpatial package, something called bake to mesh, where the particles actually are baked in runtime each frame to the meshes. This method allows us to implement custom shaders, but it's not working that is still early in the development process. since Demio initially was built with the built-in learning pipeline, we had to start the process of porting the shaders to the URP. And as you can imagine, our tech artists were super thrilled about this, since like we have few hundred shaders, yeah. So in our conversion pipeline, we use the Unity shader graph. And it's because it validates the shaders in terms of the reality kit support. And it's super useful to see quickly like which nodes of your shaders are not supported, or if the shader is exceeding the reality kit limits. And by porting to URP, we also gain the foveated rendering, which is really crucial to kind of keep the performance of the game and also manage the battery gameplay time. Because like playing the single adventure of Demio with your friends can take up like up to 3 hours, and it's nice to not lose your battery. Here you can find some example of how the game looks and before and after porting to URP. And as you can see, there are not many differences. So like shout out to our tech art team. So let's talk in summary what kind of advantages we gain. So we are pretty excited about using hand tracking combined with eye tracking. Like playing Demio with your hands or controllers can be really tiring. And being able to use the eye tracking and just having the hands in the relaxed position is really convenient, and like you can play more comfortably than the other platforms. As you might know, that we are using crossplay among all platforms which we support. And we were happy to find out that the photo networking is working really nice still within the visionOS. Having bounded, unbounded, and windowed mode allow us to give this player an option how to launch the game and just enjoy the mode they prefer. And we also are exploring how to leverage the AR kit to feel the game be more immersed. For example, during the gameplay, you can throw the die each turn, and it would be super nice if like the die could bounce among your floor, but also like the furniture and kind of stuff. When it comes to challenges, well, particles were the obvious one, and we are still in the exploration phase how to solve that. The in-game voice chat is not working currently for us, and this is because of some microphone access issues, but this might be also outdated knowledge because like the beta is changing so fast and there's a lot of fixes. It will be also super nice to leverage the environment lighting, because it's really tempting to like having your, let's say, board pieces like affected by your real light, and like having the MR mode really immersed, like the game feels almost physical. So will the MR mode look like the VR? We will see in the future. Thank you so much for your attention, and back to Matt.
Yeah, just leave it. All right, thank you, Pawel. So really that's all we had for you today. As I mentioned before, today we announced that the beta is open to Pro, Enterprise, and Industry subscribers. If you get Unity 22.3.11 and above, you can integrate those packages using Xcode 15.1, Beta 1, and above to build. And as a note, the simulator requires an Apple Silicon Mac, so actually being able to test your build is going to require Apple Silicon, but you can still develop on other platforms. There we go.
Is that available, or do you still need to submit your content to Apple?
The Unity beta is available to all Pro, Enterprise, and Industrial subscribers. Access to Apple's Developer Lab, we'll need to talk to Apple about that. But you can go to this page here to learn more about how to integrate the packages, get the right version of Unity, et cetera, and build the simulator today. That's our time. Thank you, everyone. Hope you enjoy the rest of your show.